Welcome to Maths and Science by IITian channel. In this lecture, we will be taking up a very important lecture on functions and relations, which is very vital and backbone for the mathematics. Lecture number 2. In the lecture number 1, we have defined what is the relation, and we have established that all relations are not functions, and function is a relation. It is a special type of relation where the function should satisfy the two conditions. One is, in the language of set theory and also in the language of mathematicians, we can read this condition as, for all A belonging to set A, for all elements A belonging to set A, there exists, the symbol is there exists, B belonging to B such that AB belongs to function F. A function is a special type of relation. I have already explained what is a relation. With an example, I will explain this definition. Please remember this definition. It is a very important definition. There are two conditions to be met in case of a function. The second condition is, if an element A and an element B1 and element A and element B2 belongs to the function, then B1 is equal to B2. This is the typical mathematical definition. We are going to crack it. We are going to understand in simple way what it means. Let's move further. Here, what is given? Function A to B is a special type of relation. Please remember, it's a special type of relation. It's a relation, it's a special type of relation, and if A belongs to A and B1, B2 belong to B, then the set A, there is an element A belonging to set A, and there are some elements B, B1, B2, some other elements belonging to set B, then the condition is that the first condition, for all A implies all elements in set A. For all A means all elements in set A. There exists some B in B. There exists B belonging to B. There exists means for all elements in A, when you combine these two definitions, for all elements in A, there will be an element B in B such that AB belong to that function, such that AB belong to that function. This is the meaning of it. This is the first. This is the meaning of it. Now, let us take one example. A is equal to, we have already taken 3, 5, 7, 8 example. 3, 5, 7, 8 in previous lecture. We will continue with the same. What is the cardinality of A? Is equal to 2. Cardinality of B is equal to 2. Therefore, cardinality of A cross B is equal to 2 into 2, that is equal to 4. Then number of possible subsets in Cartesian product A cross B is equal to, from A cross B we can even call it as 2 to the power of NA into NB, that is equal to 2 to the power of 2 into 2, 2 to the power of 4, that is equal to 16. Number of possible subsets. And what are the possible subsets we have come across? 16 possible subsets. There are 16 possible subsets in A, from A cross B. If I take a subset like this, if I take one subset, let us take one subset. For writing the 16 possible subsets, please refer to my earlier lecture. Let us take one subset as R12, which we have defined in the previous lecture as 3, 7, 3, 8 and 5, 7. What is my set A? Set A has got 3 and 5. Set B has got 7 and 8. And what are my relations? 3 is linked to 7. There is a relation established for this. 3 is related to 8, 3, 8. And 5 is related to 7. We have to see whether it is a function or not. Here R12 is the subset of A cross B. We have to see whether R12, that is equal to 3, 7, 3, 8 and 5, 7 is the function or not. That is our goal. From the definition of the function. From the definition, first part of the function, for all A, all elements in A. That means all elements in A are, for all A means for all A belonging to A, that is equal to 3 and 5. These are the all elements in A. Are you able to follow? Please follow it carefully. For all A, there exists, for all A, there exists B such that AB belong to function. There exists For 3 there exists 7. For 5 there exists 7. For 3 there exists another 8 also. For all A there exists B. Up to this it is okay. And if we say R12 is a function, if not, let us prove the contrary. Let us say, it is only assumption, assume R12, which is the subset of A cross B, is a function. We have to see whether it is a function or not. We are first assuming it as a function. That implies up to this point, for all A belonging into A, there existed B. There existed 7 and 8, B. Because 3 is related to 7, 3 is related to 8, 5 is related to 7. There existed a B such that AB is 3, 5, 7. That means 3, 7, 3, 8, 5, 7. AB belongs to F. Till now, because we assumed the above as a function, it is an assumption, this first rule is obeyed. Now, what is the second rule? What is the second rule? Second rule says, because both the rules have to be obeyed, AB1 and AB2 belongs to F implies B1 is equal to B2. What is AB1? Here A is equal to 3. And B1 is equal to 7. And B2 is equal to 8. A is 3. That means A, B implies 3, 7 and 3, 8. Both are belonging to F because we have assumed F. In F, 3, 7, 3, 8 both are there. But this is A, this is A, this is B1, this is B2. But B1 is equal to 7 and B2 is equal to 8. That means in the second condition it is failing. A is equal to 3, B is equal to 7, B1, B2 is equal to 8. From the definition of F, that is R12, as R12 treating it as a function we have treated initially, we will prove the contrary. 3, 7, 3, 8, 5, 7, 3, 7, 3, 8, 5, 7. If it is not a function, we will prove the contrary. Otherwise, no. Now, this is A. For the same element A belonging to set A. For the same element A belonging to set A, that is 3. We have different elements in B. From the relation what is taken? That means for the same element A, for the elements A, B1 and A, B2 implies 3, 7 and 3, 8. They belong to F. Yes, we have assumed it as a F. They belong to F. But 7 is not equal to 8. That implies B1 is not equal to B2. That says second rule is violated. What it is actually meant, that means for each and every element A of A set, there should not be more than one element in B associated. Here what is the association? When you see 3, 5, sometimes schematic will give a better idea. It is A, it is B, 7, 8. There is one relation between 3 and 7 defined in the relation, and another relation defined between 3 and 8, and another relation is defined between 5 and 7. These are relations only. Out of the A cross B, this is the relation which we have taken, and we try to understand whether this is a function or not. Now you just see. A belonging to A, 3 belonging to A. Yes, it has 2 outputs in B. That is in violation of the definition of function. Hence, in regular sense, how do you define a function? In mathematical language, I have shown you how to define a function. Now, in normal language, how to define a function, I will tell you now. How to understand it. There are many relations between A and B. And out of many relations, some of the relations are only functions. Others are not functions. Please understand that concept. And the relation which is a function, in ordinary language, it can be understood that every element in A has an association, or B is called as image. This can also be called as image. Image in B. That is the first condition. Every element in A should have an image in B. Second rule is that for any element in A, there should be only one image in B. There cannot be more than one image in B. That means, if you wanted an output by giving an input, the output should be unique. The output should be single output. You cannot have two outputs from a single input, multiple outputs. All inputs from A should have outputs in B, but every input from A should have only one output in B, but not multiple outputs. For example, let us treat this relation 9, R9 from the above example. What is R9? R9 is equal to relation 3857. 57. In this, what is its meaning? 3 is A, 5 is A, and 8 is B1, and 7 is B2. This is A1, this is A2. Sorry, A2. Is it a function or not? Let us try to analyze. This is very important topic, hence I am spending more time here. Please understand the concepts. You should not 3, 5, 7, 8. There is a relation 3 to 8 and 5 to 7. This is one relation we have. That means every element in A, please try to understand, every element in A, that is equal to 3 and 5, has an image or output in B as 7 and 8. 3 has only one output and 5 has only one output. 3 has output 7 and 5 has output 8. That means every element in A has an output. First rule is obeyed. Second rule is first rule obeyed. And as far as second rule is concerned, same element in A does not have multiple outputs or images in B. Because, for example, if I say A B1, A B2, what is the function here? Let us say this is the function we have taken as function is 3857. 38. This is the relation which we have taken it as, assumed it as a function and testing whether it is a function or not. Here let me say A B1, A B2. If A is there for only one A like 3, there is only one b. This is a, this is b, that is b1 is equal to b2, because there is nothing defined for b1, b2. One input has got only one output. A, B implies B1 is equal to B2. That means A is an input, 3 is an input, there is only one single output. Nothing is associated with 3 other than 8. Hence, it follows both the rules. Hence, F 3857 is a function. Now, there will be different examples we may have, like A is equal to, let us say one relation is there between A and B. Relation is equal to plus or minus square root of x for any value of x in A. Is it a function or not? It is a relation. A is equal to set of all x such that x is a natural number. Whatever you want to define, you can define. X is a natural number. Simple example I have taken. And B is equal to set of square root of plus or minus square root of x. Then, how it is? A will be containing, I am writing only 1 or 2 elements. There will be infinite elements. Let me say, A has 1, 2, 3. B is plus or minus square root of x. That means plus square root of 1 minus square root of 1 and plus square root of 2 and minus square root of 2 plus square root of 3 minus square root of 3. And the relation is defined as sum R. That is square root of B is equal to A. Then, in this what happens? 1 is related to square root of plus 1. When you square root of plus 1, square root of plus or minus 1, not square root, square of plus or minus 1 is equal to 1. Plus or minus 2 whole square is equal to 2. That means one element in A has 2 outputs. It has either what you call plus or minus square root of 1 or plus or minus square root of 1. Minus square root of 1 and plus square root of 1. Similarly, when you have put input as 2, square root of that will be either plus square root of 2 or minus square root of 2. If function x is defined as not function, rather I should call it as a relation because it's not a function. Relation defined as A is related to B such that B square is equal to A. I have defined, I can define anything in any way, don't worry. I am defining a relation. My values of B are plus or minus square root of A. In this case, this relation is not a function. For example, let me say function x is equal to x square for all natural numbers, some numbers. What will be the domain of my A? My domain of A will be 1, 2, 3, and what will be the range of my A? That will be 1 square. This relation is established as x square. This is the relation. This 1 square will be 1. 2 square will be 4. 3 square will be 9. Whether it is minus 1 also, it will be 1 only. It is minus 2, it will be 4 only. That means the relation is developed this way. Minus 2, 4 plus 2, 4. That means all the elements in A are defined. All the elements in A are defined, and at the same time, none of the elements of A has two images in B. None of the elements of A has two images. This is a function. Are you able to follow this? Now in this lecture what we have done, with this I want to conclude this lecture because definition of function, definition of relation is very important. In the first lecture I have defined what is relation, in the second lecture I have defined what is function, and all relations are not functions. There can be a relation existing between A and B, but all relations are not functions. All functions are relations, but every function is a relation. All relations are not functions. With this note, I wanted to conclude this lecture. If you feel there is a value addition because of this lecture to you about understanding the function and differentiating between function and a relation, please hype my lecture, please share my video and subscribe to my channel Maths and Science by IITian. In the next lecture, we will be taking up various functions, like we will be going into the details of Real problems we will be solving after this theory is over on functions. After next class, I will be going for functions definitions, continue for 2-3 lectures, and we will go for different real valued functions, constant functions, identity functions, and then what are polynomial functions, and we will be discussing rational functions, and then modulus functions, greatest integer functions, signum function. These type of functions we will be defining and we will be understanding along with the graphs. Till now we have understood what is a relation, how relations are established, and how many relations can be established between two sets A and B, and out of all those relations, how to identify a particular relation as a function as per the definition given in the function, and we concluded that all relations are not functions, but all functions are relations. With this, I want to conclude this lecture. Thank you for listening to me. Thank you for viewing my lecture. Kindly hype, share and subscribe to my channel Maths and Science by IITian. Thank you. Best of luck.